Okay, so this question, it is on page 193, okay, about manufacturing, okay. I'm going to ask volunteer to read the question, okay, all of the questions for us, okay. They read through everything here, okay. So whose turn? Kristen?
A popcorn company builds a machine to fill 1 kilogram bags of popcorn. They test the first 100 bags filled and find that the bags have an average weight of 1,040 grams with a standard deviation of 25 grams. Fill out a normal distribution curve for this situation. The middle 95% of people would receive bags between what weights? What proportion of customers would receive bags weighing at least 990 grams? Estimate what percentage of customers would receive bags weighing less than 1 kilogram. The empirical rule only works in special circumstances. A more universal way to discuss proportions of normal distribution is to use a z-score.
All right, good. Okay, very good. Okay, so let's try this question, okay, together. Popcorn company builds a machine to fill in 1 kilogram bags of the popcorn. But you know that it's a machine, right? We want to fill in a 1 kilogram, which is 1,000 gram bag for each bag, okay? Sometimes the weight for the bag is what? Slightly less than 1,000. Sometimes it's slightly more than 1,000, right? So it says, oh, they are testing, okay, these bags, okay, and find that the average weight of these bags are at what? 1,040 grams. So what is this? Our mean, right? Or mean, okay? With a standard deviation of what? 25 grams. This is our what? Sigma, right? Or standard deviation. Question 1. Fill out a normal distribution curve for this situation. How? We know the mean is 1,040 grams. Where do we put it? Always put the mean in the middle. Okay? 1,040 grams. Alright. So what is the data value which is 1 standard deviation greater than the mean? What is it? Every standard deviation is 25 grams, right? So add up 25 to this 1,040, give us what? 1,000, what? 65. What is the value is 2 standard deviation above? Yeah, use your calculator. Add this value by another 25, right? What do you get this number? 1,090. How about this 3 standard deviation above? 1115, right? And then below the mean, same thing. From the mean, subtract by 25. Keep on subtracting 25. Right? So that's good for question 1. Question 2. The middle 95% of people would receive bags between what weights? 95% is for within how many standard deviation? Remember? 68, 95, 99.7. Within 2 standard deviation, right? So, the middle 95% of the people will receive bags between what weights? 990 gram and what? 1,090 gram. Okay, so majority, or I would say 95% of people will receive from 990 gram and what? 1,090 gram. You agree with this? Because these two values give us, one is 2 standard deviation below, the other value is 2 standard deviation above, right? So 95% of the people will receive back, the weights are within these two datas, right? What proportion of customers will receive bags weighing at least 990 grams? At least 990 means what? Above 990 grams, right? So all of these data values are what? Greater than or equals what? 990 gram. How much percent of the data value, okay, or how much percent of the customer will receive bags? At least 990 gram. What is the percentage? Compute the percentage on this entire interval, right? Remember the picture we had just now, right? So that picture, 990, it is 2 standard deviation below. What is the percentage to the right of 990? Compute this percent, right? Percentage on this interval, right? So how to do that? One way is to add up everybody from this picture, or what? Compute the percentage from what? Less than the 990, right? Which is how much percent? 0.15% plus what? 2.35%. Give us what? 2.5%. 2.5% of the customer will receive what? Bags which is less than 990 gram. So what is the percentage for greater than or equals 990%? Is 100% minus what? 2.5 gave us what? 97.5%. You guys, you see that? Okay, so we would answer that there will be 100 minus 2.5%, which is 97.5% of the customer, okay, would receive bags with at least 990 grams. Okay, I'm not gonna write down everything, okay? You're gonna copy the sentence, all right? Can we move on to the next question? Question 4. Estimate what percent of customer would receive bags weighing less than 1,000 gram. Where is 1,000 gram on this table from this graph? Where's 100 gram? 1,000. 1,000 gram is between 990 and what? 1,015. So I would say it is here, more closer to 990. Okay, so this is 1,000 gram. Okay, we want to compute percentage of customer would receive bags less than 1,000 gram. So what is the percent of the customer will receive bags less than 1,000 gram? If this 1,000 gram fall on any specific data values? No, okay? Because the 68, 95, 99.7% rule will only work for what? If there are what? 1 or 2 or 3 standard deviation above or below the mean. If a data value fall between those data values, we're not able to use what? The 68, 95, 99.7 rule. So that's why it says here, empirical rule only works in specific circumstance. A more universal way to discuss proportion of normal distribution is to use what? Z-score. Okay, so that's why I said, okay, in this section 15, okay, section 15, the first part is the normal distribution, 68, 95, 99.7 rule. The second part we talk about what? Z-score. Okay, so let's move on to look at the Z-score, alright? Alright, let's turn to page 194. Okay, so important, alright? So, yeah, because it says Z-score is a more universal way, okay? So let's look at it, okay? Let's look at that, okay? Still, I'm going to ask volunteer to read everything, I would say, above the specific question. Okay, above the specific question, you read everything on the top. Okay, everything on the top part of the page. Okay, so whose turn? Morgan?
Recall the total area under the normal curve is 100% or 1.0. Due to symmetry, the area to the left and to the right of the mean is 50%. The bottom row of the graph lists z-scores. A z-score of -3 represents 3 standard deviations to the left of the mean, and a z-score of 2 represents 2 standard deviations to the right of the mean. Z-scores typically range from -3.5 to 3.5. The z-score is a number of standard deviations from the mean. The formula for calculating the z-score is z equals the value minus the mean divided by the standard deviations. Recall the manufacturing example to example 1,040 grams and standard deviation of 45 grams. Calculate the z-score for a bag that weighs 100 or 1,000 grams. Z equals 1,000 minus 1,040 divided by 25 equals -1.6. Thus, a bag weighing 1,000 grams falls 1.6 standard deviations below the mean.
Okay, very good. Okay, very good. All right, so we talk about z-score. Okay, so let's understand z-score. What does z-score mean? Okay, remember previously we talked about, these values, they are 1 standard deviation above the mean. Okay, this theta value is 1 standard deviation above mean. Then we say this value has z-score what? 1. Okay, so z-score give us what? How many standard deviations of the value is away deviation from the mean. Okay, so z-score is a number of standard deviation from the mean. So 2 standard deviation above the mean, z-score is 2. Okay, while 3 standard deviation below the mean, the z-score is what? -3. Okay, how about when z-score is 0? When z-score equals 0, that means this data value is a mean. Okay, is a mean. Okay, so z-score is more, it's more like what? For a number which is how many standard deviation from the mean. Okay, all right, how to compute the z-score? This should be on your formula sheet. Okay, for any given values, okay, from the question, okay, compute the z-score of this number, of the value, okay, of this value. It is computed by what? Value minus the mean divided by the standard deviation. You have to remember the formula, the order, okay, in the formula. It has to be the value minus the mean divided by the standard deviation, or x minus mu divided by sigma. See the example, the previous question, we're going to compute, okay, what is 1,000 grams of a bag, okay? So the z-score for this 1,000 gram is 1,000 minus mean is 1,040 divided by the standard deviation, which is 25, and it gives us what? -1.6. What does this -1.6 mean? Means a bag weighing 1,000 gram is what? 1.6 standard deviation below the mean. Okay? Yeah. So let's see. From the 68, 95, 99.7 rule, we only talk about when the z-scores are integers, right? -4, -3, and integers. Then now with z-score, we may have what? 1.6 below, okay? 0.5 above, okay? So it's more universal way, right? Okay, now let's practice some questions, okay? Let's do some practice questions, right? So I assigned the entire page, okay, but let's do some question, okay, as practice, okay. Andrew, can you read question and question 3 for us?
Let's look at an example. The average adult male approximately equals 70 inches in height, and we will use a standard deviation of sigma equals 5 inches. Find the z-score for a man who is 6 feet 2 inches tall.
Okay, good, thanks. All right. So, average adult male has a height of 70 inches. Okay, well, 70 inches in feet and inch is what? Average feet is 12 inch, right? So it's going to be 5'10". I think it's 5'10". Okay, so you know, okay, 5'10" is like that height is average, okay? So 70 inches average. And also, average standard deviation is 5 inches. Question 3. Find the z-score for a man who is 6 feet and 2 inches tall. How to find the z-score? Remember we just learned the formula for z-score, right? Z-score equals data value minus what? Mean divided by what? Standard deviation, right? So what is the data value? 6 feet 2 inches. Can we use 6'2" directly? No, because both the mean and standard deviation, they're given by what? Inches only. So we have to convert 6 feet 2 inches into inches. So it is going to be what? 6 times 12, 72 plus 2, 74 inches, right? Alright, so 74 is our value. Minus mean, what is mean? 70. Divided by standard deviation, what is it? 5. So, you get a 4 out of 5 is what? 0.8. Okay, so a man with 74 inches tall is what? 0.8 standard deviation above the mean, right? I think 6'2" is very tall. See, it's not even outside of 1 standard deviation. It is still below, within 1 standard deviation. You see that? Yeah, so 0.8 standard deviation above the mean. Well, 6'2" is pretty tall, I believe. Okay, so think about this. Okay, so that's why we talked about 6-8% of data value are what? Within the mean. Okay, 1 standard deviation of the mean. All right. Okay, so this is a practice question for us to compute the z-score. You can try those questions, okay, later, either in class or after class, okay. Okay, so now we learned about what? The z-score, okay, z-score. Now let's continue to look at what? Probability, okay, probability, okay. This is another question for us, okay. This is I would say, do we use this? On page 195, okay, on page 195, yeah, I would still say that, let's talk about page 195, and still I'm going to ask some of you guys to read, okay, everything above the table, okay, about the z-score table, okay. So, whose turn? Leila?
In the previous section, we learned about the area under the curve for values 1, 2, and 3, standard deviations from the mean. We can use these scores in the table below for values that do not fall directly on a standard deviation. The z-table below gives the proportion under the normal curve to the left of the given z-score. These proportions can also be referred to as probabilities. Example, what is the z-score for a man who is 63 inches in height? Z equals value minus mean divided by standard deviation equals 63 minus 70 divided by 5 equals negative 1.4. Using the table below, a z-score of negative 1.4 corresponds to the probability of 0.0808. This means we would expect 8.08% of men to be shorter than 63 inches. What proportion of men is taller than 63 inches?
Alright, thanks. Good. Okay. Alright, so this is actually an important part, okay? It's important part, okay? Example, we want to find the z-score of a man who is 63 inches tall. Okay, so because we know average height is 70 inches and every 1 centimeter is 5. So for a 63 inches tall man, 6'3" is only 5'3". Okay, about my height, I think, you know. For a man, 6'3" is we can imagine it's a shorter guy, right? Shorter guy. Okay, so coming to the z-score for this guy, it is what? 63 minus 70 divided by 5 give us what? Negative 1.4. Okay, so his height is what? Negative 1.4 means it's out of 1 standard deviation below. Okay, so if we mark negative 1.4 for z-score, It is between -1 and -2. Okay, so for example, z-score equals -1.4. It is here. Okay, so that means for 63 inches tall man, okay, his height is 1.4 standard deviation below the mean, right? And we want to compute how much percent of the men who are what? Shorter than 63 inches. Okay, so how do you find this percentage? To the left of the when z equals -1.4. How to find it? From the z-score table. Okay, and for z-score table, I just want to emphasize for one thing. The z-score table gives a proportion or percentage under the normal curve to the what? To the left of the given z-score. It has to be to the left of the given z-score. Okay, so let's check from the table, guys. Each z-score column has a corresponding probability. Okay, z-score column probability. Let's find when z equals -1.4 from the table. Do you see that? Okay, so when z equals -1.4, what is the corresponding probability? 0.0808. This is the decimal number. Okay, so this decimal number 0.0808 in percentage, it equals what? 8.08%. Okay, and this percentage is telling us what? 8.08% of the men are expected to be what? Shorter than 63 inches, to the left of 63 inches. Okay, so the table of the z-score only gives us a probability, which is what? To the left of the given z-score. Okay, now the question is, what proportion of men is taller than 63 inches? How to find this percentage? Find the 8.08%, which is shorter than the 63 inches, and then use what? 100% minus 8.08% give us a 91.92% of the men, they are what? Taller than 63 inches. You guys? Yeah, here I just want to emphasize that z-score table only gives us the probability is to the left of the z-score. If you want to compute the probability is to the right of the z-score, what do? Use 100%, subtract by what? The given probability. Then you will figure out greater than the z-score, what is the percentage. You guys? Okay, now I think we're ready for doing application problem. Okay, now we know how to compute the z-score. Okay, also we know the z-score table. Now let's start to do practice question. Okay, on page 196, 197. Okay, I assigned both pages for you, but I don't think we can do all of the 6 questions on both pages. So we're going to do some of the questions. Okay, I would say let's try question 1. Okay, and then we're going to do one more. Okay, we'll do one more. So I would say, how about the IQ score problem? Okay, so we'll do question 1 and 6 together, and then you do the rest. Practice, okay, by yourself, right? Okay, so question 1. Okay, this is what? This is the Danny question. Okay, there are 4 sub-questions. I'm going to ask a volunteer to read all of the questions for us. Whose turn? Stephanie?
Yeah. After Danny DeVito is 5 feet tall, what is the z-score for Danny DeVito's height? What proportion of the population of men is shorter than feet?
C?
So C and D. Using your value from part B, determine how many men out of 100,000 you would expect to be as short as or shorter than Danny DeVito. What is the probability that a man is taller than Danny DeVito?
Okay, very good. Thanks. All right. Okay, same height question. Okay, me the same, standard deviation the same. Okay, Danny is 5 feet tall. What is the z-score for Danny? 5 feet in inches, it is going to be what? 60 inches, right? Alright, z-score for Danny is going to be, what is a given value, what is value for us? 60, what is the mean? 70, standard deviation, what is it? 5, so, negative 10 over 5, exactly negative 2, that means Danny's height is 2 standard deviation below the mean. Okay, so Danny is short. Remember, within 2 standard deviation, 95% of men are within 2 standard deviation, right? Well, not just men, okay, 95% data value are within 2 standard deviation. So Danny's height is 2 below the standard deviation, okay? Alright, what proportion of the population of men is shorter than him? Negative 2 is here. Compute proportion means percent. Probability. So what is the probability? Check the table. When z equals negative 2, what does the table tell us? Only 2.28%, right? I would say 2.28% of men are shorter than Danny. You go with this, right? Okay, and then this table you can read it by yourself, okay? Compares with z-score method and also the empirical methods, rule method, okay? You can read this by yourself then, okay? Question C. Use your calculation from part B, determine how many men out of 100,000 would you expect to be as shorter as Danny. 2.28% of men are shorter. Out of 100,000, how many? What do we do, guys? 2.28% of 100,000 men, right? So how? Use 0.0228. Well, you use 2.28% times by what? 100,000, right? Yeah, because this is 0.0228 per one person, right? And then per 100,000 means times by 100,000. What do you get? We should get 2,228, right? You get the same answer, right? So that means out of 100,000 men, about 2,228 men are as shorter as Danny.
2,280, isn't it?
Oh, you're right. Thanks. Yeah, I made mistakes. Thanks. Okay, let me know, okay? 2280, okay? Because we moved the decimal point to the right for, I would say 5 digits, right? So 2280, you're right. Good. Okay, question B. What is the probability that a man is taller than Danny? This is percent of men are shorter. What is the probability that a man is taller than Danny? Give us what? 97.72%, right? You can answer. This much of percent of men, okay, are taller what? Taller than Danny. So far so good, everybody? Now, if we summarize the idea for a z-score problem, at first, what's the first step? Find the z-score, right? What is the second step? Find the z-score table, okay? So, if you understand these 2 steps, you should be able to answer most of the z-score problem. And be careful, this percentage given in the z-score table are for what? To the left of the given z-score. If you want to compute the percentage which is larger than, what do we do? Use 100% minus the percent, okay, given in the table, right? Alright, so let's move on to look at question 6, okay. Christine to read the question? Kathleen?
The average IQ score is mu equals 100 points with a standard deviation of sigma equals 15 points. What is the probability of selecting someone at random with a score under 120 points? Write a sentence interpreting your answer.
Okay. IQ score 100 points, this is the mean, okay? Standard deviation is 15. What is the probability of selecting somebody at random with a score, bless you, under 120 points? So how to do this problem? Mean, standard deviation, what is the value? 120, right? So first, we are going to compute what? Z-score, right? So Z equals, how about you tell me? How to find the Z-score for 120, value 120? Formula. What is the value? 120? Yeah, minus 100 divided by what? 15. So, Z-score, we should get a 1.33, right? Yeah, or you get a 1.33. Now let's check the table. When Z equals 1.33, and let's find out the percent. Oh, there's no when Z score equals 1.33. So 1.33 is between 1.3 and 1.4. So which probability should we choose? So which Z score should we use? We want to find the more closer value. 1.3 is more closer to, 1.33 is more closer to 1.3. So we're going to use when Z score equals what? 1.3. This probability is 90.32. Okay, so that means 90.32% of data value is less than what? The value when the value has Z-score 1.3. Okay, so here, okay, this from the table, it gives us what? 90.32%, right? So what is the probability of somebody is IQ 120 points and less? What is the percentage? 90.32%. Write a sentence to what? Interpret our answer, okay? So how to interpret this answer? We expect that what? 90.32% of people, okay, will have an IQ score, okay, of 120 points or what? You know, right? Yeah. So 90%, if your IQ score is 120, you're in a 90th percentile. Okay, 90% of the people will be less than you. Okay. Well, same question. I'm going to ask you one extra question. You don't have to write down, but you can answer me. What is the percent of people whose IQ score is above 120, or at least 120 points? How much percent? Use 100 minus this, right? Give us what? About 9.68% of people whose IQ score is what? Above, or at least what? 120 points. Do you see that, everybody? Okay, so these are the Z-score questions.